Hi, it's time for another math easy solution. Trying to discuss just an example on higher derivatives. What I mean by this is if you have a function, let's say y equals f of x right here. So if you were to take the derivative, you get basically y prime is equal to df of x over dx, and this would just equal to, you could write it as y prime or whatever, or f prime of x. But then if you were to take the derivative of the derivative, you're just basically getting into higher derivatives, and then you'll get something like y double prime. So this could be written as the same thing as going like this, y bracket 2, meaning the derivative, the second derivative, and this would equal 2d of, you could write it as d of derivative of f of x right here. So you could kind of write it in many ways, and this would just equal to, you could even write it as d squared of f of x over dx squared. So the 2 is on this, on the d here on the derivative, and this squared is on this one here. I'll explain that in a bit. And then, or you could even write it as double prime of x, or f bracket 2 of x. And the reason that this for the notation, this is squared, is if you were to think about units, if you have, let's say, y is let's say meters, then the derivative, let's say x is in seconds, let's say y is in here I'll write it better. So let's say y is in meters, x is in seconds, and the derivative, you're gonna be dividing by the seconds, or the rate of change in terms of seconds. So you're gonna get the derivative is gonna be meters over seconds over s. As you can see, that the top part is stayed the same, but then now as you're taking more and more derivatives, the bottom is adding a unit here, seconds. And if you were to take a derivative of the derivative, you'll get basically the rate of change of meters per second over second right here. So then this unit's going to be meters, it's going to get meters per second squared. So that is why you always write the squared in front of this x here, or whatever it is at the bottom. Just because the units change, and on the top one you don't put it in front of this one because the units remain the same, whichever what y was. And you can see this from acceleration. For example, acceleration is going to be meters per second squared. Even if you look at acceleration due to gravity, you have this squared there, this second squared. So now, anyways, let's go over this example. Basically, example the states if f of x equals x times cos of x, find and interpret the second derivative of x right here. So basically this is taking derivative twice. So first we find a derivative, we'll get df of x over dx, or just write f prime of x. This equals to, using product rule, the derivative of this. Remember, any related videos, you can see those in the video links below, like proof of product rule, derivative of cos, etc. So anyways, so derivative of x is just going to be 1 times it by cos. We just times whatever this function is, and now we add, now we write derivative of x. No, we just put x, we don't take derivative, and now we take derivative of cosine of x, and that is just negative sine of x right here. So simplify this, we'll get cos of x minus x sine of x right here. So now this is the first derivative, so the second derivative, we just take derivative of the derivative. So we get derivative of cos of x, that is just negative sine of x. So now we use product rule on the right side again, so just put the negative out there. Now we're going to have the derivative of x is going to be 1, so we just write sine of x. And now we plus derivative of, we just put x, derivative of sine of x, that is cos of x. These brackets don't match, but anyways, the same thing. So now we'll have negative sine of x. Just simplify it. We'll have a negative sine of x. Put the negative inside. And negative x cos of x right here. Oh, it's a bit messed up. Anyway, so now we add these up. Negative sine, 2 sine of x minus x cos of x right here. So this is f prime of x. So now the second part of the question says interpret this, and you can interpret it actually through graphing. I'm going to graph it with Google Graphing Calculator. So already here I have graphed the 3 functions. The blue one is just f of x right here, so I'll put f there. The red is the derivative, f prime, and then the orange is the second derivative, f prime, or f double prime. So now, as you can see from this curve, remember the first derivative is the rate of change of the function f. So then basically whenever you have Yeah, whenever you're basically, as you see, you're changing. Whenever you have a horizontal slope, because remember it could be interpreted as the slope of the tangent line. So if you have tangent line here of derivative of f prime of 0, yeah, at this point here the derivative has to be 0 because there's a horizontal tangent, and as you can see, as of the f prime, there it is, it's 0 right here. And basically you have positive slope whenever basically f is increasing, but then as it is decreasing like this one, you're gonna have a negative slope or derivative. And then the f double prime is the exact same thing as this, except now you're dealing with the rate of change of this function right here. So then whenever you have a, let's look at this part here, whenever you have a horizontal tangent to this derivative, then the derivative of the derivative, or the second derivative, has to be 0 right here. And as you can see, it is 0. So this part here, f double prime, has to be 0. So, and then also when, as you see, when this is positive, so as you see, this is positive, this function is increasing, and then when it is negative, in this case, as you can see, you are decreasing. So basically just the exact same as derivative is to the regular function, but now it's to the derivative. So it's the rate of change of the derivative. Well, yeah, anyways, yeah, actually, just one more thing. This can be considered as the acceleration of the function. Yeah, in the same way that if you're driving a car, basically the rate of change of your velocity is your acceleration, or even gravity, that's an acceleration, or is a double derivative of position. Well, anyways, that's all for today. Hopefully you learned from this example, and also this pretty interesting part about this x squared. I just realized why the notation's like that now. Hopefully you like that part. But anyways, remember, you can download these exact notes in the Dropbox link below. And thanks for watching, and stay tuned for another Math Easy solution.